All right, so just a minute. Yeah, Likit, I'm sending beta. Huh? Yeah, so last time we were talking about. Yeah, I'll send that recording beta. Just it's being uploaded right now, so I'll send the recording and the whiteboard notes of yesterday's doubt session. By today evening, I'll send it. Right, so we'll just wait a couple of minutes for the non-integrated students to join in. They're just going to log in now. Okay, so I think more or less everybody is logged in now. Let me just check one more time. Right. Right. So we were discussing about pulley systems, simple pulley system, and tension in strings, etc. last time. So today's lecture is going to be more about problem solving and sort of revision lecture of all those kind of things, because you have the test coming up on Sunday. So we will look at mainly practice problems based on what we've learned in the 5 sessions so far. And also I will be giving you a couple of worksheets to do revision questions like that. So let's start with an example based on what we learned last time. So we have this situation now. We have, let's say, a system of 3 blocks like this, and they are connected by light threads, okay, or what we can call massless threads. Now, one more important aspect about these threads and strings we should understand at this stage. Not only they are very light, so we can call them massless. Now, of course, nothing is perfectly massless. Mass zero to nahi ho sakta unka. But the thing is, their mass is negligible compared to the mass of the blocks, etc. So we can call them approximately massless. A better way of expressing is that we'll say that they are having negligible mass, or that they are very light. Okay. Now, second aspect of all these threads and strings is they are also inextensible. So inextensible का मतलब क्या होता है? That they are having such a structure that, unlike a flexible material like rubber or something, is unlike that. They are like nylon or some steel wire or something like that. So they don't stretch. So when they are under tension, their length does not elongate. Okay. So this is an important point, and we'll discuss more about this. There are, let's say, 2 external forces which are acting. All 3 of them are identical in mass, but we have 2 different amount of external forces acting like this. Okay. So this force is F1, this force is F2. And let's say these blocks are labeled A, B, and C. So the proper language of a question like this will be something like this, that A, B, and C are 3 blocks of identical mass connected by light and inextensible. You will see this word very often, and even if you don't see this word, you will have to assume that our standard threads and strings are always inextensible. So I'll come back to that. Okay. On and they're placed on a frictionless surface. Okay. Initially at rest. Okay. Now, two horizontal forces, okay, F1 and F2, are applied as shown. So these forces are applied simultaneously. Okay. So given that suppose the mass of each of these blocks is 2 kilograms and F1 is, let us say, something 25 newtons and F2 is, let us say, 10 newtons. Okay, we want to find the acceleration of the blocks. Okay, and we want to find the tensions in both strings. There are two different strings, so they will have different amount of tension. Within a string, the tension will be uniform, but the two different strings will have different tensions. Okay, so before we get into the question, let me explain one important point over here, what we mean by this and what is the significance of this light and inextensible threads, okay, or strings. Let's understand the meaning of this. So okay, light and, okay, I'll check the answer. Strings or threads. Okay, so what do they mean? Light implies that the mass is negligible. Okay, so tending to zero. And inextensible implies that the thread or string does not stretch. Okay, or elongate under tension. Okay, so they are basically non-flexible. You can say like this also. Yeah. So it's like, unlike, for example, a rubber band. Okay, a rubber band is an example of something which is flexible or extensible, like that. So generally speaking, in this chapter, whenever we talk about threads or strings, we are always referring to this kind of material. So even if the question doesn't specify explicitly, you will always have to assume that they are inextensible. Okay. All right. So now let's work out the values of acceleration and tensions. So Aditya, acceleration that you've given is in meters per second square, right? Each of the masses is 2 kg, okay? And the forces are 25 and 10. So how much will be the acceleration? Yeah, meters per second. No, not that. Okay. 7 by 3. Nee. Kevin, all of you are getting this. Okay. Let me check. Okay. 2.5 is the correct answer. Correct. 2.5 meters per second square is the correct answer, or 15 by 6 or 2.5. Okay, now the first thing you can understand here is, see, F1 is dominating because, so the system will tend to accelerate like this, will accelerate towards the right. Now all the three of them will have acceleration towards the right. And secondly, because जो दोनों strings है वो inextensible है, that means the length of the string does not change, so the distance between A and B remains constant, so they will have same acceleration. Similarly, the distance between B and C should remain constant, so they will have same acceleration. That's one point. And the other point is that because the strings are massless, so the tension is the same throughout a string. So this tension T1 will be equal to the tension at the other end T2. And similarly over here, if the tension in this string at this end is T2, then at this other end should also be T2. Yes, acceleration will be 2.5 meters per second square, or 5 by 2 or 15 by 6 or whatever. Okay. So this is connected to the fact that the strings are light and inextensible. Okay. So another, within this point, you can keep in mind this thing also, that massless or light threads or strings always have uniform tension throughout their length. So that's one important thing. Okay. And secondly, because the threads are inextensible, that is why there is no relative motion between the blocks. Okay, because the threads are inextensible. Okay, so the distance between A and B and B and C remains fixed as they move. Okay, and that is why the acceleration of the block A will be identical to the acceleration of the block B, will be identical to the acceleration of the block C, which we are taking as E. So this is another important aspect when we are solving the problem. Now, once we are clear about this, rest is about solving the free body diagram. So next thing is, as we apply Newton's laws now, all we have to do is apply the free body diagram concept properly. Okay, so free body diagrams of all three bodies. That's the fundamental way of solving. So when I look at the free body diagrams of the blocks A, B, and C, I can show them as particles, I can show them as blocks also, it doesn't matter. Okay. If I want to be very exact, I should show them as particles, but still. So here, the force F1 is acting like this, or whatever, F2 is acting like this, and F1 is acting like this. So taken, yeah. So this was F1, which was 25 newtons. This was F2, which was 10 newtons. Okay. Then there was some tension in this thread. Okay. So let's say that was T1, and then there was some tension in this other thread. So that was acting on this block. Okay. And then all three had common magnitude of horizontal acceleration. So यहाँ पे we don't need to do any resolution of forces. All the forces we have shown are horizontal, and vertical forces are anyway balancing. So there's nothing else you need to do. No, there are four tensions. मतलब two threads, so tension at the end of each thread. No, you understood. So as I've shown in the diagram, so these are my blocks A, B, and C, and all three of them have the same mass. And all three will have the same magnitude of acceleration. Why? Because we just discussed the threads are inextensible. So all three have a fixed distance between them. Okay, so yes. So now let us write the equations for each one of them. So summation fx is equal to ma. That is the equation for all of them. So for A, the equation will become T1 minus F2 is equal to ma. For B, the equation will become T2 minus T1 is equal to ma. Okay. And for C, as you can see, the equation will become F1 minus T2 is equal to ma. That's my third equation. So I have three equations and three variables. T1 is unknown, T2 is unknown, and acceleration is unknown, and I've got three equations. Okay. Now, of course, here there are vertical forces also, but they are balancing each other. So we don't really need to worry about the vertical forces. There is weight and normal reaction on each one, but they are all the same and they are balancing each other. So we don't need to worry about the vertical forces. Of course, if you are showing the complete free body diagram, you should show the vertical forces, because without the vertical forces, they are incomplete. No, but nonetheless, these are all balancing. So इसका कोई significance नहीं है ना? So n is equal to mg in all the three blocks cases. So all we have to do is solve these equations. So what you can do here is, if you line them up together like this, you'll see that if you add the forces, add the equations, your T1 and T2 get cancelled out. So if you just simply add the three simultaneous equations, you will get F1 minus F2 is equal to m plus m plus m a. So parametrically speaking, we'll get the acceleration as F1 minus F2 divided by 3m. Okay, and numerically that will become 2.5 meters per second square. That's the first thing. Okay, and now substitute this in equation 1. So you'll get T1 minus F2, which was 10, is equal to mass, which was 2, into acceleration, which is 2.5. So you will get T1 as 15 newtons. Okay. And substitute this in equation 3, for example. So you'll get the value of T2. So you'll get F1, which was 25, minus T2 is once again 2 into 2.5. So T2, as you can see, will become how much? It will become 25 minus 5, or 20 newtons. So that becomes the second tension. Okay. So this is the complete solution of the question by using the fundamental free body diagram method. Now we can actually shorten the solution a little bit using some tricks, and I will discuss that next. But fundamentally, the way to solve by the basic concepts, which all of you should know, is this. No, mass of each block is 2, Baba. Mass is not 6. Mass of m is equal to 2, beta. Mass of each block is 2 kilograms. And F1 was 25 newtons and F2 was 10 newtons. These are the values given. The three equations are coming by applying Newton's second law along the x-axis. Summation Fx is equal to ma. So just look at the free body diagram of block A. The net force along the x-axis is T1 minus F2. So that's equal to ma. Similarly for block B, similarly for block C. Net force is equal to mass into acceleration. No, this equation we've applied for all three blocks. That's why I've written this over here. So when you apply it to block A, you're getting equation 1. When you apply it to block B, the diagram is just above. So you have to just correlate these two. This is child's play. There's nothing difficult in this. Okay, people. So hope the equations are clear to all of you. Okay, now as I was telling you, Yeah, we can. That's correct, Viraj. We can do that, and that is like a shortcut method. So I'll just explain to you. Yeah. So alternately, we can do one more thing over here. This is like a shortcut trick we can use. Okay. Whenever multiple bodies move with identical acceleration. Now, what I mean by identical acceleration is that their acceleration vectors should be identical. So not only the magnitude of the acceleration, but direction should also be equal. So here you can see that is happening to all these three. Okay. So whenever that happens, we can consider one single free body diagram of the bodies combined as a single one. Okay. So let me explain how that is happening over here. So in this particular example, we can see that the three blocks A, B, and C, because they are tied together by massless strings, and because they are all on the horizontal smooth surface. So जब मैं उनको pull कर रहा हूँ, doesn't matter which side I'm applying the force from and how much force I'm applying. But if they are going to move, that means if one of these two forces is dominating over the other, okay, they are going to move with common acceleration. So we saw immediately that they will, all three of them have common magnitude of acceleration and common direction of acceleration. So they have identical accelerations. So this acceleration, and this acceleration, because the strings are inextensible. So the three particular blocks in this case, A, B, and C. So in this example, acceleration of block A as a vector is equal to acceleration of block B as a vector is equal to acceleration of block C as a vector, which is E, suppose. So that E is nothing but that magnitude I cap, if I take this as my x-axis and y-axis. Okay. So because ये हो रहा है यहाँ पे है ना, तीनों ब्लॉक एक साथ मूव कर रहे हैं, therefore now I can consider A plus B plus C as a single body. Okay, single combined body. Okay, and make the free body diagram for it. So that is the shortcut I'll apply. And when I make the free body diagram for that entire combined mass, then any forces that are acting inside that system, that is T1 is acting within the system, T2 is acting within the system. So this will become internal force. So they will cancel off in action reaction pairs. So now I will consider this whole thing A plus B plus C as a system or as a combined body. Okay. So when I do that, what will happen is the tensions being internal forces within the system. Why? Because it's the force that A is applying on the string and the string is applying on B. Okay, so within the system of A plus B plus C, okay, therefore they cancel in action reaction pairs. Okay, so for that system A plus B plus C, only external forces count for the second law. The net external force is equal to mass into acceleration. So the tension will not count over here. And a summation of T will become 0. Okay. So what we are doing is now we are considering this whole thing as one system. So when we are considering this whole thing as one system, is becoming a combined body of total mass 3m, combined body A plus B plus C. और इस पे external forces क्या act कर रहे हैं? The ones which I am showing. F1, F2, the combined weight, okay, and the combined normal reaction. Okay, so these are my external forces, and that whole system is moving with a horizontal acceleration E. So I can just now simplify this whole thing and make it a free body diagram, like a proper free body diagram where the whole system is represented by a dot. So this is my system, which is A plus B plus C. So it has a mass of 3m. So the forces acting on that system are horizontal forces F1 and F2. Okay, and vertical forces, the total weight and the total normal reaction that the ground is applying. So 3 mg and 3n equal to 3 mg. So they cancel each other, but these forces are 25 newtons and 10 newtons. So the system has a horizontal acceleration of E like this. And now writing the equation for the combined system, okay, F1 minus F2 will become combined mass, which is 3m into A. So you see what we had got by solving the three equations, we are getting directly in a single term now. We don't have to add those three equations separately and do this. This is coming in one step, and therefore it is a shortcut trick. Okay. Now, once we've got the acceleration, mind you, to get the tensions in the individual threads, we have to go back to the individual FBDs. Now, we cannot escape that, but still the number of steps will be less. Okay. So first note down this whole concept. Okay. We will see it applied not only in this problem, but in a number of problems today. So this trick that we are talking about, that the shortcut method, that whenever multiple bodies move with identical acceleration E, we can do this. We can make it a combined single free body diagram. I'll explain how to calculate the tensions, don't worry. But first write down this part, or at least understand it in detail. Let me just expand this a little bit so you can understand better. Okay, just a minute. The syllabus for major test 3 is up to the last lecture, like lecture 5 of Newton's laws. Today, most of the things we are doing are basically revision. So it is entire portion of vectors and Newton's laws up to the single pulley system. The next thing we'll study in Newton's laws is going to be non-inertial reference frames. That's why you will see that the syllabus says it excludes non-inertial reference frames. So today's session is a revision session. Okay. We are not going ahead in theory and anything, but it's practice and revision. Okay. Now see, once we have got the force, the next thing is how do we get the tension? For that, we have to make the individual FBDs, free body diagrams of at least 2 of the blocks. So these blocks are A, B, and C. Now, to find out the tensions, okay, single block FBDs are used. So for example, if we make that FBD for the block A, then on A we can see that there is tension T1 from this side and force F1 from this side, and the acceleration is A. So T1 minus F1 is equal to MA. So now you substitute this over here. So T1 minus 10 is equal to 2 into 2.5. And from that you will get the acceleration as, I mean, you will get the tension T1 be 15 newtons. Okay. Then you can make the FBD of B, for example. So in the FBD of B, there is T1 from this side, there is T2 from this side, and it's having the same acceleration A. So the equation will become T2 minus T1 is equal to MA. So T2 minus 15 is equal to 2 into 2.5. So T2 will come out to be 20. So even in the shortcut method, you have to look at the individual free body diagrams if you want the tensions. But typically in a question, if you're looking only for the acceleration, then you don't have to do so many things. You have to just make the combined free body diagram, and from one equation, you will get the acceleration E. Yeah, you can consider first and last also. You can consider any 2 of the 3 blocks. Now you can take A and B, A and C, or B and C, because you have 2 variables left, T1 and T2. Okay, people, so hope this is clear. Okay, so now let us pick up an example which has a little bit more complexity in application. Because the block is moving towards the right, no? We can see that the block is moving towards the right. So T1 has to dominate over over F1, Somarup. Understood? Or was this F2? Sorry, this should be F2, no? Just a minute. I'll make a correction to just make a correction here. This should be F2, not F1. This is the block A, no? Block A पे इस तरफ कौन सा force लग रहा है? It is F2. But I've written the value correctly. It is 10 newtons. Okay, but just the labeling of this should be F2, not F1. Just make this correction, people. Okay, this is the force F2. Okay, now let's come back to another question based on similar ideas. हाँ तो तभी तो माइनस साइन के साथ आया ना. That is why the net force came out to be T1 minus F2 ना. See, that's why in this equation, the net force is T1 minus F2 because it's in the negative direction. Is it clear, Samarth? Okay. Now, next example, we have something like this. We have again a combination of two blocks. Okay. Lying on a frictionless surface. But this time they are connected by a thread on this side. Like this. And the thread is going around a pulley like this. Okay. So this is like a table or something. Okay. Yeah, the pulley is fixed. Okay. So far we have discussed only fixed pulleys. We'll start discussing other types of pulleys later. Okay. And then the thread going around the pulley on the other side is used to suspend another block. Okay. So let us say this block is mass m1, this block is of mass m2, this block is of mass m3, and this is a smooth horizontal surface. Okay. And of course gravity is acting vertically like this. Okay. So all the threads, that is there are two threads here, one joining m1 and m2 going around the pulley, and the second one joining m2 and m3. So it's better to say both threads. So both threads are light and inextensible. Okay. And the pulley is smooth and fixed. Now we discussed what is the meaning of fixed and smooth here last time, that the pulley cannot rotate about its axle. That is the meaning of fixed. And the surface of the pulley is smooth. And that is the meaning of smooth and fixed. So this axle of the pulley where it is attached, it's a fixed axle. And this surface of the pulley where the thread is going around it, its surface is frictionless. That is the meaning of smooth. So the thread slips without any friction or without any hindrance from the pulley surface. Okay, so that is the meaning of this. So the pulley is smooth and fixed, and the surface on which M2 and M3 are placed is also smooth. Okay. Now the system is released. Yeah, all will be of smooth pulleys in this chapter. Yeah. So now the system is initially held at rest with both strings just about taut. So just about taut का मतलब क्या है? We are holding the blocks in such a way that the thread here is not loose. The thread is taut. This is taut. It's not lax. Similarly, the other thread is also taut. Okay. So given that M1 is equal to, let us say, 4 kilograms and M2 is equal to M3 equal to 3 kilograms. Okay. Find their accelerations. Okay, so let's work this question out now. Sorry. Yeah. Just try this out now. Yes, Kevin, very good. That's correct. Take G as 10 meters per second square. Okay, so you got the correct answer as long as you've taken G as. Okay, now about this you have to be careful. In certain questions, G will be given as 10. In certain questions, it will be 9.8. No, so if it's 9.8, you have to take accordingly. No, Parth, you have to check your calculations once more. Okay, so let us analyze the question first. Okay, so let me just copy this diagram first. Okay. Now let us understand few things which are very important in this diagram first of all. So the first thing you have to understand is that because there is a thread of fixed length, joining M1 and M2. So if M1 comes down by a certain distance, M2 will move by the same distance. Okay, so the downward motion of M1 and the motion of M2 towards the left has to be identical. And again, inextensible thread between M2 and M3. So whatever distance M2 moved towards the left, M3 also has to move identically towards the left. So if they move identical displacements, their velocities will be identical. So will their accelerations. So M2 and M3 have identical accelerations, whereas M1 has, we can't say identical acceleration because acceleration is a vector, but it has the same magnitude of acceleration downwards as the leftward acceleration of M2 and M3. Okay, so that is the first point to understand over here. Okay, the downward acceleration of M1 is identical to the accelerations of M2 and M3. Okay, but of course they are towards left. Okay, they are horizontal. Okay, towards left. Okay, in magnitude. Okay, so that's the first thing to understand. And second thing is that tension in each thread is uniform through the thread. All right. So because there is a thread joining M2 and M1, so whatever downward motion M1 has, M2 will have to have identical motion horizontally towards the left because the total thread length is constant. So that is why इसका जितना भी downward acceleration A है, this one's horizontal acceleration A is same in magnitude. And again, inextensible thread joining M2 and M3. So same about M2 and M3. They should have identical acceleration. So that was that point. And then of course, if this one has tension T1 here, that tension is also acting, same magnitude of tension is acting on this because tension is uniform. Yeah, it's a constrained motion in that sense. Okay? And then whatever tension in this thread, which is acting towards the right on M2, same amount of tension will act towards the left on M3. So same tension, so it will be this. Oh God, again I made that mistake. It's the same tension T2. All right. And apart from that, of course, there are the forces which are in this case the weight of this block. So that is M1G. And in the cases of these two blocks, the weights are balanced by normal reactions. So there are two weight vectors, M2G and M3G, but they're not going to be important for us because we know that they are getting balanced by normal reactions. So they have only horizontal motion, these two blocks. Okay. So if these blocks are now, suppose I'm labeling them A, B, and C. So I now want to use the equation that net force is equal to mass into acceleration. So for the block A, the net force should be downwards. So it should be M1G minus T1, and that should be equal to mass into acceleration. For the block B, the net force is towards the left. So it is T1 minus T2 is equal to M2A. And for the third block, it is T2 directly is equal to M3A. That's the third equation. Okay. And as usual, for solving them, it's very simple. What we can do is we can just add the three equations and get rid of the tensions T1 and T2. So just add the three equations. So we'll get just M1G, T1, T1, T2, T2 is cancelling out, will become M1 plus M2 plus M3 into acceleration. So acceleration here will just become the weight of this block divided by the total mass of the system. So that is becoming, the masses were 4, 3 and 3. So this is 4G upon 4 plus 3 plus 3. So it will be 0.4 G or 4 meters per second square. And if you want to find the individual tensions T1 and T2, now you can substitute this in each of the equations and get the values of T1 and T2. So this is the combination of forces which are acting over here. Now, thoda sa we could have simplified our problem by using that shortcut method. Here, B and C are moving together. They have identical acceleration. So we can combine them into one object. Okay. So if you want to use that shortcut trick that we saw last time, you can do that also. Okay. So just make a note of this first and then I'll discuss the shortcut trick. But it's very important that you learn how to solve every problem by proper fundamentals first. Okay. So don't be in a hurry to apply shortcut when you're practicing at home and all that. Okay. Just take your time, understand each system, make the diagram properly, make the individual free body diagrams properly. Okay, make sure that you haven't left out any force, make sure your sign conventions are correct when you're writing the equations. Pay attention to the fundamentals and do some practice, and you will see you will not make any mistakes while doing questions. Because there's a thread joining M1 and M2. That is what I explained multiple times, Sarvesh, कि M1 अगर 1 सेंटीमीटर से नीचे जाता है, M2 will have to move by 1 centimeter along the negative x-axis because the thread is of fixed length. So they should have identical magnitude of displacement, therefore identical magnitude of velocity. Velocity is differentiation of displacement, and identical velocity means rate of change of velocity is identical in magnitude. So acceleration will also be identical. You can understood the point. Okay, good. Now let's come to the slightly shortened version of the solution. The this thing that we can use shortcut. Since M2 and M3 have identical acceleration, vector, mind you, M1 does not have identical acceleration vector. Therefore, we can combine them into a single body of mass M2 plus M3, in this case 6 kg, and make its free body diagram. So let's see how that works. So if I am to do that, we will consider M2 plus M3 this whole thing we'll consider as one single body. Okay, so on that single body, now you'll see that there is only the tension from this side acting. And that combined single mass is having an acceleration towards the left, which is E. Okay. And of course, on the other side, we'll have to consider the FBD of the other block. So this is M1. और इस पे क्या forces लग रहे हैं? There is its own weight, and there is the same magnitude of tension, but it's acting vertically upwards. So T1, and it's having the same magnitude of acceleration but downwards. Okay. So now we have two FBDs only. So the amount of work we have to do is a lot less. So for M1 plus M2 combined, when we write Newton's second law, it will become T1 is equal to M1 plus M2 E. That's one equation. And for, sorry, not M1 plus M2, my mistake, M2 plus M3. Yes, there are plenty of problems like this in HC Verma, you'll find. Okay. Okay. And for M1 as a single object, the free body diagram equation is M1G minus T1 is equal to M1A. And now you can see to solve for A, just add the two equations. So you just get M1G is equal to m1 plus m2 plus m3, which was the equation we had got from the other three equations also. You can see that this is identical to this equation we had got here. When we combined these three equations, we got this equation here. This equation is the same as this one. So that is the application of your shortcut trick. Okay. So once you are practiced with the fundamentals properly, this kind of shortcut tricks and all will help you at the exam level a lot. Pulley is not exerting any force on M2 and M1 beta. Pulley is not attached to M1 and M2. The thread is attached. The thread will have the same tension because it's massless or very light. Pulley's story is different. The pulley's disc is experiencing tension force and some kind of reaction force from its hinge. But the pulley is not moving along with these, so we don't need to consider the pulley. All right, so this is done, I hope. Okay, next is a problem for you people to solve as a practice problem. So now we'll start including the concepts of inclined planes also along with this. Okay, so okay, so we have this situation. Yeah, I'll come back to that, Sarvesh. So ये angle 53 degrees है, ये angle 37 degrees है, और ये दोनों smooth surface है. Okay. So this is okay. Now we have a fixed smooth pulley. Okay. And a thread which is going round the pulley, and on the other side is attached to two blocks. Okay, so just to keep things simple, we'll keep the masses of the two blocks the same. Okay. So blocks A and B are of identical mass, m equal to 5 kg each. Okay. Initially held at rest with the thread which is light and inextensible. Taut. Okay. So now, as they are released, simultaneously, find their accelerations and the tension in the thread. So just start this problem, people. Okay. And you can also find the normal reaction forces. Take G as 10. Yeah, that's correct. Aditya, that's the correct answer for acceleration. Okay, so these are both fixed surfaces. Yes, Kevin, acceleration is correct. Tension are... Yes, tension is also correct. 35. Summer, check your answer, please. Aditya, ulta. Normal reactions are... And also, matlab, they'll be multiplied by G also, na? So, to multiply your answers by 10. But see, A will have less normal reaction compared to B because A is on a steeper slope, no? No, Yojit, beta, acceleration is not correct. So I'm just giving you the answers now. Or just take a minute more, okay? Just do your calculation carefully once more. Those of you who got it incorrect, just try the calculation more carefully. Yes. So let me give you the answers now. Devansh, you got it correct. The acceleration will be 1 meter per second square in magnitude. Okay. The tension in the thread will be 35 newtons. And the normal reaction on the block E will be 30 newtons. And the normal reaction on the block B will be 40 newtons. And also they will move like this. This block will be coming down and this block will be going up because their weights are same, but that one is on a steeper slope. They have same magnitude of acceleration, but this sort of directions. Okay. So to do the question, one key thing that I'll remind you about is the directions in case of inclined plane. So always keep this rule of thumb in mind, like we've discussed. If you draw the inclined plane and at any point you draw the normal to the inclined plane, okay, and similarly you draw the horizontal and through that point you draw the vertical, okay. So always keep in mind ki whatever angle this theta, the inclined plane's angle with the horizontal, the normal is at the same angle with the vertical. This angle is theta. Okay. So therefore, for example, when you have a vector like your weight, and you have a vector like your normal reaction, yes, I will solve this question, but I'm asking you to try it out yourself. Okay, so this component of weight is the cos component, not the sine component, in terms of this angle theta. And this component of weight is the sine component. Okay, so you have to keep this in mind. Okay, good. Devansh, you got the other answers also, normal reaction and tension. Okay, so just keep this rule of thumb in mind. Okay, similarly, when you have an inclined plane on this side, same thing applies. है ना, inclined plane अगर ऐसा है और कोई point पे मैंने उससे normal ऐसा draw किया है, the same concept of angles applies here also. Okay. So if this is the inclined plane's angle, then this angle will also be the same, theta. So whatever angle the inclined plane makes with the horizontal, the vertical makes the same angle with the normal to the inclined plane. Okay, so let me convert that into free body diagrams here. So let the tension in this string be T. There's only one string, so we need not write different. It's the same magnitude everywhere, the tension. Okay. So now let's make free body diagrams of the two blocks A and B separately. So when I consider this block A, इस पे क्या क्या forces लग रहे होंगे? There'll be its own weight. So weight is acting vertically downwards. Okay. There'll be the tension in the string, which we saw earlier. That is along the inclined plane. So the tension is in this sort of direction, parallel to the inclined plane. And there'll be the normal reaction which the surface is applying on it. That will be along this direction. It will be along this perpendicular direction. This is the normal reaction that the surface is applying. This is along this line. And the tension is along this line. Okay. So here now this angle will become 53 degrees because of this right angle triangle. Okay. ये angle 53 degrees. And the block A is accelerating in which direction? It's accelerating along the inclined plane. Okay. And similarly on the other side, we have the block B. So on that also similar forces are acting. Weight is acting vertically downwards. So same mass, so same weight. Okay. Tension will act along the inclined plane. So tension is acting parallel to the inclined plane. Normal reaction will act perpendicular to the inclined plane. So normal reaction का direction ऐसे होगा. So this is the normal reaction on B, and it's acting along this direction. Tension is acting along this direction. Okay. So once again here, this angle will be 37 degrees. And this is accelerating parallel to the inclined plane but upwards. So इसका acceleration का direction ऐसा है. Okay. So next, resolution of the forces. So for A's free body diagram, what we'll do, we'll take the direction of the acceleration as our x-axis. So this will become our x-axis. And the direction perpendicular to the or normal to the surface, that will become our y-axis. This, okay. For this one, we will take the direction of the acceleration, that is this as our x-axis, and the direction perpendicular to that in which normal reaction is acting, this will become our y-axis. Okay. So now we have to resolve the forces. So only one force has to be resolved in each case. mg has to be resolved. So यहाँ पे, when I take components of mg, okay, this component will be how much? It will be mg cos 53, and this component will be how much? It will be mg sin 53. So the components of the weight along the inclined plane is mg sin theta. So in this case sin 53, and into the inclined plane is how much? Mg cos 53. Similarly, when I take the components of the weight on this side, okay, so normal वाला component कितना हो जाएगा? mg cos 37, and tangential वाला या along the surface parallel to the inclined plane कितना हो जाएगा? mg sin 37. So these will be the, okay, so So remember, in free body diagram method, what we do, the steps of any free body diagram equation. Okay. First step, make the FBD, that is, draw the particle and draw all forces or all force vectors. Okay, that's the first thing. Second, take XY axis as per convenience. Means whatever is easier. So here the convenience is X axis is along the acceleration. So for each one I've done that separately. Okay. And then third step, resolve forces. So here only one force needed to be resolved, mg, and then summation of fx is equal to ma, and summation of fy is 0. So those equations have to be written. So I'm coming to the equation solving part, but first of all, just understand the free body diagram. So I've taken separate resolution for the body B and separate resolution for the body A. It's not a common system for A and B. Unke FBD is actually separate. Understanding the point? Again, Ronak, acceleration has same magnitude because the thread joining them is inextensible. So its total length is constant, no? Magnitude of acceleration is same for A and B because the thread is inextensible. This is a very important point to understand here. No? So every factor has a special importance when we are writing the equations. Now see, when you're making a complicated FBD like this, it's a good idea to circle out any force which you have resolved, so that you will not by mistake resolve that force again or consider it twice. So when I'm writing the equations, now I'll only consider this tension, normal reaction, this component of weight, the sine one, and this component of weight, the cos one. I'll not consider mg because I've taken its components. So I've circled out mg. Similarly here I've circled out mg because I've already taken its components. So you need a lot of patience to carefully, do questions like this with all the angles properly written, not make a mistake with the components and things like that. Okay. And that is what this whole chapter is about actually. No, it's not a very lengthy chapter, Samarth. Okay, so this is clear, I hope. Now let's come down to writing the equations. Once you got this. So now we have to do the last step of the free body diagram equations. That is, we've resolved the forces, but we have to now apply Newton's second law. This step we have to do. Okay. So for block A, okay, along the x-axis, that is down the inclined plane, we have positive of mg sine 53 because it's along the positive x-axis, but minus of tension because the tension is acting opposite the acceleration. So that is equal to ma. That is equation 1, let's say. And along the y-axis, the forces should balance. There's no motion. So there is positive normal reaction, but negative y-axis along mg cos 53. So that should be equal to 0. So that's our second equation. What are unknowns? Tension is unknown, normal reaction normal reaction, and acceleration. So we have 4 unknowns, and we will get 4 equations because we've got 2 from body A, and similarly for body B, we'll get another 2. So along the x-axis for body B. Now for this time for body B, the x-axis is this direction. It's not down the inclined plane, it's up the inclined plane because acceleration is up the inclined plane. So it is T with a plus sign and mg sine 37 with a minus sign, and that is mass into acceleration. Yes, that's correct, Somru. Okay, and along the y-axis similarly, normal reaction is acting along the positive direction, and mg cos 37 is acting along the negative direction. So, okay. So now you can see that 2 and 4 will directly give you the normal reactions. So nothing else is required. Whereas 1 and 3, they have to be solved to find out. So this is directly giving me the normal reaction is mg cos 53 for this one. So that is 5 into 10 into cos 53, which is 3 by 5. So normal reaction for E is 30 newtons. Okay. And this one similarly is directly giving me mg cos 37. So this will directly give me that this normal reaction is 40 newtons. And this makes sense. जो ज़्यादा steep slope पे है उसका normal reaction कम होगा. जिसका slope is less steep, that will have a stronger traction against the surface, so it will have more normal reaction. Okay, and now equation 1 and 3 we can solve in that same manner. Just add the two equations. So you see, you have got mg sine 53, so that is nothing but 4 by 5 mg minus t is equal to ma. That's your equation 1. In this I'm just writing sine 53 as 4 by 5. Okay. And similarly your equation 3 is becoming t minus 3 by 5 mg is equal to ma, because I'm writing sine 37 as 3 by 5, or you can even write them as 0.8 and 0.6. That's also useful. And now you just add the two equations, so you get rid of your tension, and directly you will get 4 by 5 minus 3 by 5 mg. On the other side is 2 ma. So we'll get our acceleration as g by 10. Okay, and then substitute this in equation 1 or equation 2, whichever, and you get your tension as 35 newtons. So this is the equation solving part now.
I called Dave and offered him a ride. He said no.
Okay, people, so hope this is all clear. Okay, now let's practice a few questions of the previous type, before we are done tension and all that, those type of questions also, focusing more on contact forces. Though actually those are easier questions, as I'm sure all of you would have understood by now. But anyhow, for the sake of practice, let's do something. So next example again for you to solve. Like this. Yeah, inclined plane only typically will focus on, because then at least components you have to understand properly. So this is theta equal to 30 degrees, and this is a smooth inclined plane. Okay, and now we have, let's say, a combination of two blocks like this. Okay. So let's say block A and block B, and also we have a force that we are applying, an external force, but we are applying it parallel to the inclined plane like this. Okay, so this is given to us. Now the question is now like this, that given that mass of block A is, let us say, 15 kilograms, mass of block B is, let's say, 10 kilograms, okay, and an external force F is being applied continuously up the incline. Okay. but obviously parallel to it. Okay. Such that what we are observing is that the system is having an upward acceleration of, let us say, 2 meters per second square. Okay, so such that A is equal to 2 meters per second square. Okay, so take G equal to 10 meters per second square and find F, then the contact force between A and B. Okay, and the normal reactions on A and B by the inclined plane. Yeah, they are in contact. So obviously you're pushing them from below and they're accelerating together. So they will have to be in contact, na beta? When you're applying a large amount of force and they are actually moving up, they will have to be in contact. It cannot be that they are not in contact. No, Dhruv, it is not correct. The value of F you've written. Somewhat not correct. No, it will be 150 newtons, I think. None of you have got it correct so far. Kevin, just check your calculation once. Okay, now the first hint to you is that, see, A and B are accelerating together, no? They have common acceleration. So you can combine them into a single body. So it becomes a single body of 25 kg, which you are pushing up the inclined plane. So उस पे net force up the inclined plane कितना हो जाएगा? F minus mg sin theta, where m is the combined mass. So that should be equal to ma. So just apply that. So according to my calculation, your F should be mg sine theta plus ma. So the combined mass is 25 kg. G sine theta is this thing 5 plus A is 2. So 25 into 7. So 175. Yes, F should be 175 newtons. Okay. Whereas the contact force between A and B should come out to be 2/3 of this. So 3. No, I'm not giving you the calculation here. I'm still asking you to do it yourself. I was doing the calculation in rough. Okay, so I've given you just a hint so far. Make FBD of A plus B as a combined body because they move together. Okay. So just do this and you will get the answer for this thing, the force. And then for the contact force and normal reactions and all, make individual free body diagram. You'll get the answer. So that's what I'm doing first of all, making the combined free body diagram. So just follow the steps. Okay. Okay, so 25 kg is the total mass. Now the weight will be the vector which is pointing downwards. Combined weight. Okay. Then there will be some combined normal reaction because of the surface on both of them. So that will act along this perpendicular direction. Okay. So this is N as normal reaction on A plus normal reaction on B. Okay. So here this angle will be 30 degrees. And then you are applying the force up the inclined plane, the external force. It is like this. So we don't know. Okay. But its direction is along that direction. And under the action of these forces on the system, force is 175 bit. I've already given the answer on top. Okay. So under the action of all these forces, the acceleration of this combined mass is along this direction. and that is given to us as 2 meters per second square. Okay. And also we know that this weight will become 250 newtons. Okay. So what we'll do now is we'll take this as our x-axis, the direction along the inclined plane as our x-axis, this as our y-axis. So we'll resolve this mg. That's the first thing to do. Resolve mg. So mg के components ऐसे हो जाएंगे. This component will be mg cos 30, and this component will become mg sin 30. Okay. So this is the key thing now. This free body diagram is the key thing. Okay. So now along the inclined plane, what is happening? The net force is F minus mg sin 30, and that is equal to mass into acceleration. So F will become m into g sin 30 plus a. So 25 into 5 plus 2. So F will become 175 newtons. This is how to do the first part of the question. Yeah, Archit, this is the only type of test. और क्या आएगा इसके बाद? There is non-inertial frame, which we'll discuss next week. Yeah, Devansh, I'll show the rest of the question. Just a minute. Friction is, yeah, but it will come later. There are many more things in Newton's laws. This is the only first part of Newton's laws chapter, up to the pulley system, single pulley system. Normal reaction on A and B, like that we'll get. Okay, now to find out the other things, we have to make the individual free body diagrams. Okay, so now let's come to that part. Now let me start with the free body diagram of the block A, and then we'll move on to B. So A पे क्या क्या forces हैं? Let's see. So there is its weight. Okay. There is normal reaction that the ground is applying. So that is along this direction. Okay. There is the external force that was being applied, that was on A. So that also we found out now, it's 175. But there is also some force that B is applying on A because they are in contact, and that will be like this. That will be down the inclined plane. So N is the contact force. It's again normal contact force only between the blocks A and B. Okay. And under the action of all these forces, Under the action of all these forces, now you can see that this block is having an acceleration of E along this direction. That acceleration was 2 meters per second square. Okay. So as usual, our resolution will be, the direction of acceleration is our positive x-axis. Okay. So for the block A, what are our equations? Achha, we have to still resolve mg. So let's come to that first. So now this is all becoming very standard, nothing difficult. So isko resolve kar lo. So this component will become the cos component, and this component will become the sine component. So this is okay. So for E along the x-axis, my equation is becoming f minus mg sine theta minus n is equal to ma. So this will actually give me n. So I'll have 175 minus this mass of A was 15 kg. Okay, so minus 150 into half minus n is equal to 15 into 2. So this equation will actually give me the value of the normal reaction. This will give me the contact force between these two. N will come out to be 175 minus 75 minus 30. So 100 minus 30, 70 newtons. Okay. And along the y-axis, forces are balancing. So Na minus mg cos theta should be 0. So this will give me now that the normal reaction due to the surface on A, the inclined surface, will be okay. So that is okay. So now we have only one thing remaining, which is the normal reaction on B, which will obviously be its weight's cos component. So see, you're pushing against the block A with a large amount of force which is making it accelerate like this. So block A will be pushing against B, and B will be pushing back, action reaction pair. So A B को ऐसा push कर रहा होगा and B A को वापस ऐसा push कर रहा होगा. So this is the contact force between A and B. Is it clear, Somarup? Okay, good. '70 is the, I've written there, but N क्या है? It is a contact force between A and B. Archit, I've written down what is N. See there in red it's written. It's the contact force between the blocks A and B. Just now we were talking about that only. No. Now similarly in the same diagram only we can make the FBD of the block B. Don't need to complicate things so much by making so many separate diagrams. So for the block B, you can see that there is its weight acting downwards. Okay. which is 100 newtons, by the way. There is normal reaction on it, which the ground is applying. I mean, the inclined plane is applying, which is like this. And there is now, very importantly, the force with which the block A is pushing it. इसका जो counteractive force है, this force. Okay, and this all together is creating the acceleration, which is the same along the inclined plane. Okay, so same treatment for this. This as your x-axis, this as your y-axis. This angle is 30. No, so resolve mg. So you have mg cos theta, mg sin theta. Okay, and you have similar equations for b, therefore. Okay. So actually the x equation you need not write, because you've already found out the value of n, but it will just show you that you'll get the same thing. You'll get n minus mg sin theta is equal to ma. So you can also see n by this method. So 10 kg into 10 into half plus 2. So that's again verifying that n is equal to 70. So this was not required because we'd already found this. Okay. Whereas along the y-axis, you can see that the normal reaction that the surface is applying is balancing its weight's normal component. Okay. So this becomes the complete solution of this question. Let me minimize this a little for. Yes, yes, I'm going to share the worksheet now. Just give me a moment, guys. I'll just send you the worksheets. So on your Blue House and non-integrated groups, I've shared two workbooks. They are like revision worksheets. Workbook 1 is very easy. It is just the, very basics of Newton's laws. Won't have difficulty. But workbook 2 has a lot of examples of free body diagram examples. Okay, various types of free body diagrams. So I will be sending you, the answer key kind of thing. I mean, more like the solution of workbook 2 by the end of this week. So by then, please attempt this properly. Yes, I am sending you the notes also. Yes, it will have integer answer type questions. So the test will be like this. Per subject, there will be 20 multiple choice questions and 5 integer answer type questions. Okay. For NEET, there will be 45 in physics, 45 in chemistry, and biology 90 questions or whatever. NEET will be NEET pattern, and for JE, there will be JE mains pattern. Okay, the same pattern you have seen in major test 2 also, that one only. No, HC Verma you can, yeah, HC Verma also there are some questions you can work out. I'll send you a list. Okay. But the 2 workbooks I have sent, particularly workbook 2, try to make all the free body diagrams in the next 2-3 days, and I will send you a sort of this thing. Okay. So that's it for today, people. Okay. With this, concluding the session. All right, so all the best. Prepare hard for this test coming up, and make sure you do a revision of all the worksheet 1 and 2 which I've sent earlier, and the revision workbook 1 and 2 that I'm sending today.